We are on functions. Functions, there are 4 of them. Each of them we're going to sketch as well as find the equation. We've looked in the previous lesson for the sketch. Now we're going to find an equation. All old work. Grade 9 work. When you were told that if you have a line through 2 points, how do you find the equation? Now by the way, I've called this line G. So if the line is G, then I can make my equation Gx. Let's talk about that again, about the function notation. First of all, if I give you 2 points, you're going to use the gradient formula, which is also an analytical. So the straight line is super important because you're going to use it in trig and analytical and graphs. So everywhere there's a straight line. So if you don't know the straight line, you're tripling your defeats. Everything that's going to go wrong is going to go wrong triple 3 times in all those sections. So if I've got to go do this sum, how were you taught in grade 10? To go say x1, y1, x2, y2. I'm not going to write it there, but that's a good idea. So that when you substitute it in, and it doesn't matter if this is x1, y1, or if this is x2, y2, then this will be x1, y1, and that doesn't matter. But you can't call this x1, y2. Okay, so point 1 is x1, y1, point 2 is x2, y2. So when we substitute, we have negative 5 minus 3 on top of negative 2 minus 4. Now, it's fine to write it that way, but I want to quickly help you to always do it in a quicker way. So when we do it in a quicker way, it's going to be a minus times a minus is a plus. The moment that I do it, I say minus 4 is becoming a plus. So just to save a little bit of time. Punch it into your calculator, it's minus 8 over 2, which gives me negative 4. So we've got y is equal to negative 4x plus c as our equation. What are we short? What are we short? We're short c. So if we need to find c, I'm making a note of this. Wherever you go in an equation and you are short one variable, ma'am, is there just one variable here? Yes, ma'am, there is only one variable here. In a straight line equation, how many unknowns are there? 2. M and C. X and Y are not unknown. X and Y are part of the formula, and they represent on your straight line all the millions and trillions and billions of infinite points, coordinate pairs. So the X and the Y have to be there. You've only got one variable, namely C. So for that C, in all of your graphs, straight line, parabola, hyperbola, exponential, the moment that there's one variable, and when you go further with grade 12 work, when there's one variable, how do you find it? Substituting a point. Which one? It doesn't matter. It doesn't matter. Choose one. Mostly people choose the one with the least negatives, because you always tend to make mistakes with negatives. So you're substituting negative 4 and 3. So in the place of y, there's a 3, and in the place of x, there's a negative 4. Just make sure you don't put it in the wrong one. And like you were taught in grade 8, accurate substitution. This gives me 16. Take it across becomes minus 16. Together with the 3 is negative 13. So that my equation, please don't think you're finished because you've done all the work. Give me the answer. The answer for this equation of the straight line is y is equal to, I found the m first, and now I found the c, and that's my straight line equation for marks. Oops, I missed the minus. Thank you. Minus 13. Right. Happy? Straight line finished. Let's go to the parabola. So the next function or graph that we're doing is the parabola. Now you know the parabola from grade 10, but the difference between grade 10 and grade 11 is that in grade 10 there was never a B part. So that effect was that you always had parabolas in grade 10 that were symmetrical about the y-axis or something like that. And you can still remember the shape, right? What determines the shape?
The Y.
The A. If the A was positive, it's a smiley face. If it's negative, it's a
Surface.
Okay. So in this example, let's do it on the hand of steps. You're always going to do the following. You're first going to tell me that the shape of this one is smiley face. Turning point, because you need the turning point. Now, how many points are on a graph? A lot. But what are the important points that I must show if I do the parabola? Obviously, well, it doesn't matter where it turns and what happens, but you need the turning point. Then you need the y-intercept and the two x-intercepts. Can I find a few other points as well? Yes. But if you find any random 2 points, is that going to show you what the graph looks like? No. Like in this straight line? No. So you need to have all these values. So in your solving or sketching, first determine the shape. Then we have the turning point. Now the turning point last year was easy because the turning point and the y-intercept were the same. Are you with me? Now it's not. Now you're getting a new formula, more study work. For the x value of the turning point, you will say minus b over 2a. Where should we see something like that? Remember? The quadratic formula, wherein I know that this is the discriminant. Discriminating whether it's real or rational or irrational or whatever. And now let's look at this. That's the PC that you use. It's just a method of remembering it. It's not really doing that, okay? Just to remember it. If you work with that minus b over 2a, you're going to get the x value of the turning point. You have to believe me. You can go check why it is that way. So, once you know that formula, and that's a good way of remembering it, what must you do to find the turning point? What's b? Okay, excellent. You know that a is 1, b is negative 2, c is negative 8. So in the place of b, we've got negative 2, which means a positive. I could have just as well written a positive there immediately. And then 2 times a at the bottom is 2 times 1. That gives me, use your calculator if need, the answer is 1. Calculator. But that only gives me the x value. The turning point has an x value and a y value. Any point has an x coordinate as well as a y coordinate. So when you go and you find your x, you still need to find your
y.
How?
Substitution.
For every x there's a y, for every y there's an x. If I have one of the two, substitute it in and you'll get the other one. So if I need to go substitute the x in, same again with your grade 8 way that your teacher told you, substitution into x with 1. Meaning you go to your calculator, you fill it in and the answer is? It's negative 9, you're right. Right, so the turning point then is 1 and negative 9. Are you happy with that one? So far I can even go sketch. 1 and negative 9 is somewhere there. But ma'am, how can you say that? Remember, we're busy with sketch graphs. Approximately. I'm not going to make 1 and minus 9 there. 1 is a little less, y is a little bit more, minus 9, but it's not exact. So the point 1 minus 9 I've already got, the turning point. Right, then obviously we still need the x and y intercepts like you did in grade 9, grade 11, grade 10. So for the y-intercept, what do? Make x 0. If all else fails, that's your fail-safe. For an x-intercept, you make y equal to 0. For a y-intercept, you make x equals to 0. But also, you were told long ago and last year that that's also your
y-intercept.
So if you just know it and tell me, ma'am, the y-intercept is, or you can even say c is equal to negative 8, I'm happy with you. But if you did go and say x equals 0, gone. X equals 0, gone. What's the answer? Negative 8. So if all else fails, for the y-intercept, you put x equal to 0. For the x-intercept, you put y equal to 0. Okay, so I can do that already. Minus 8 is going to be my y-intercept. Now I still need my x-intercepts. I already have a good idea. If now, already you're sketching it, and you don't give me the x-intercepts, you're going to lose marks, but you're going to get some marks because you're on the right track. If you at least show me that it's a positive happy phase parabola. How will I find x-intercepts then? Like y equal to 0. And if I do that in this graph, y, remember fx is y, 0 equals, and we're back to what? Quadratic equations that you've done millions of now. How do I solve that? Equal to 0 factorized. Okay? What are the factors? Now guys, you should be able to do this in your sleep now. Factorizing shouldn't be a problem anymore. And then your x values were 4, negative 2. X values negative 2 or 4. Then I must at least try and make it a little bit logical. Don't make the negative 2 there and the 4 there. Okay, it's not accurate, but approximately. And when I sketch it, I try my very best to make it look at least symmetrical. I'm not quite happy with my attempt, you see? Okay, but it's fine. Not too much, but I try my best. That's it. Full marks if I say to you, sketch the parabola. But I want to see the x-intercept, I want to see the y-intercept, I want to see the turning point. And then you can name the graph, F, since man has named it, F. Few things of importance. The axis of symmetry. Is there a symmetry axis in the parabola? What does a symmetry axis mean? I have a symmetry axis and you do too. If we cut me in half here, then you don't have a math teacher anymore. But the left and the right should be approximately the same. Okay, so symmetry means left and right, there's like a mirror. Where's the mirror here? There's the mirror. You see it? Yes. That's why you should try and sketch it symmetrical. But please tell me, what is the equation? I'm so happy that you don't say 1. It is? X is equal to 1. You're actually doing it here. When you're doing the turning point, it's always the x value of the turning point. Has to be. X value of the turning point. Do you see it? Everything must gather together. But please not 1. Any vertical line or horizontal line, like we spoke about in the straight line, you've got to be able to get their equations. Vertical lines are where x stays constant. Horizontal lines are where y stays a constant. And that's a mark, or maybe even 2. Next question. Domain and range. What are the domain and ranges of all the graphs? What does it mean if I talk about the domain?
Yes.
Domain is the x's and the range is the y values. How do you remember that again? Alphabet. D comes before R. X comes before Y. Okay, domain and range. It's just a way of remembering it. So you will say, okay, the domain of F, let me just write it this way. The domain of F will be dot dot. Which x's do I use in this sketch? And it was the same last year with a grade 10 parabola. What are the x's that you're using? Ma'am, I only use that one and that one and that one. No, that's not what I'm talking about. Remember how many points are on this graph? A lot. Infinitely many. And the x's range from where to where?
Infinity.
Negative infinity up to?
Positive infinity.
Okay, so what do I say?
Element of all real numbers.
That's it. Same as last year. Because it was still all the real numbers. What are the y values? So we say the range of f are. Is the range also all the what? All the numbers? No, it stops where?
At the turning point.
At the turning point at -9. So it's all the y values
Bigger.
bigger.
Or equals to negative 9.
Or equal, because it does equal the -9 as well. And then I can ask you something like, give me the minimum and the maximum of this thing. Well, this one has a minimum value. A smiley face will have a minimum value. And the minimum value is y is equal to -9. These are the questions I can ask. Do you do that every time you do the sketch? No. When you sketched it, x-intercept, y-intercept, turning point, and you're done. You don't have to write shape as long as the shape is here. So in a test, when the shape is at least right, you're going to get 1 mark on the graph. Not for saying it over there, on the graph. Okay. Okay, new one. So last year you did ax squared plus bx plus c. That previous one, ax squared plus bx plus c, that's the general format of a parabola. This is a new one. We call this turning point format.
Oh.
Should remind you of something. When you have a bracket square, what should have happened to it? How do we make a square? We complete the square. How? From ax squared plus bx plus c. Yes, by quadratic equation or quadratic expression, you do completing the square. Then you can write it in this format. And here is the wonderful use of it. Once you've done it, because we did mention it when we were busy with those equations or expressions, now we're in a parabola equation. It's now going to be the turning point. When we were busy then, I said this expression, what is the maximum or the minimum? Who can remember? Where did we see the maximum or the minimum after completing the square? You saw it there. I taught you that about 2 months ago. That will always be your maximum or your minimum in an expression when you've done completing the square. But now, okay, I'm saying that the general equation then is A still. Oh, there's no A. Yes, there is. The A is 1. Positive 1, right? So tell me what the shape is.
It's a smiley face.
Is that A the same A as in ax squared plus bx plus c? Yes, otherwise they would have called it another name. Okay? Is that, okay, we'll get to that just now. So the P and the Q is something else. Now you're learning that it's the turning point. So now you must remember the following. Turning point you can just now give me. You don't even have to work it out with minus b over 2a. You're just going to read it off here. Guess. It's that P and that Q. The turning point is going to be P and Q. But take a note of this. I wrote minus there, but I'm saying plus there. X's?
Oh,
It's the girls. It's the girls. X's.
The opposite.
Minus 2 should be? So the turning point is plus 2. And? Negative 4. That's a boy. Negative 4. That's fantastic. I don't have to do anything. I just read it off. As long as you from this second remember that one changes sign and that one doesn't. Alright? So I can immediately go to my sketch already and say the point 2 minus 4 is about here. That's going to be my turning point. Fantastic. Even if you draw a sketch now with that shape, you've got 2 marks. Right shape and turning point. Okay, but what do I still need?
X and Y intercept.
Alright, X and Y intercept. Oh, the Y intercept is that negative 4.
No.
If it was, it would have been called C.
Yes.
Like in ax squared plus bx plus c. It's not. That's Q. And Q only tells me the value of the Y value of the turning point. How do you get the Y intercept then?
Make X equals to 0.
If you make X equal to 0, what will Y be? Exactly as it is. Substitute the X with a 0 and answer please.
0.
It's 0.
How?
Ooh. Can the Y intercept be 0?
Yes.
Of course. So I'm pretty sure this is what's going to happen to my graph. And that one I just have to go figure out. Actually, you can figure it out now without working it out. Tell me about symmetry. From there to the turning point was how many units? 2. So from there to there should be 2. So that should be no problem. No marks deducted. Because it should be symmetrical. Are you with me?
Yes, ma'am.
How would you normally do it though? X intercept you put? Y equals to 0, so 0 equals. And again we have a quadratic equation. in a quadratic equation, how do we solve for x? Get it equal to 0 and then factorize. There's another method here. I can either time out this whole thing, get the equation, do factorization, or even maybe the formula, because it doesn't have to go through 2 and 4 or 6 and 8. It doesn't have to be rational answers when I work out the x-intercepts. Or can the x-intercept be something like root 5? Are you with me? And how will you get that? With the formula. So all of this stuff comes into practice. When you're solving an equation, you've got to take into consideration all of the things you've been taught. So it can be something that cannot factorize. But the easier way for me is if I'm looking for x and there's only one x at the moment. If it's ax squared plus bx plus c, you can't do what I'm doing now. But there's one x. How can I get that x alone? Take the 4 across. And then? Square root it. But the moment that you square root it,
Plus
you should
minus.
write plus minus. Otherwise, you're going to get only one answer, and you shouldn't. If you're busy with x-intercepts, you should be getting 2. Sometimes 1, which will be when your parabola just touches the x-intercept, and sometimes nothing. If the graph is, for instance, over here, then it won't have x-intercepts. You'll be searching for it and finding no solution because it doesn't have x-intercepts. Alright, so this will be plus or minus 2 equal to x minus 2. How do I do that sum? So it's 2 equal to x minus 2 or negative 2 equal to x minus 2. Two different solutions. Linear, right? Okay, solving for x, it's to 4. Solving for x, it's to 0, because negative 2 plus 2 gets me 0. So if I want to put that on my sketch, it confirms x has to be 0 if the y was 0. If the y-intercept is 0, one of the x-intercepts should also be 0. It can't be something else. It's going through there. So it just confirms. And we were right in just thinking logically. If you got the turning point on the one x-intercept, which was just a phenomenon in this specific case, it's not going to happen every time. You have the one x-intercept and the turning point, you can look at symmetry and look at the transformation from x at the turning point. Because now again, I can sketch the line of symmetry, axis of symmetry. And it should then be 2 units to the right, because that's 2, right? And 2 units to the left. Logical. Right, that's it. Done and dusted. So what have I taught you today? You can either be asked to sketch the parabola if it's in turning point form, then you say, thank you, because I've given you the turning point. If you want to time it out and make it ax squared plus bx plus c, and do the previous x is equal to negative b over 2a, you're wasting time, but it's going to be right. Are you with me?
Yes, ma'am.
That's why I'm teaching you. If you get ax squared plus bx plus c, you get the turning point with x equal to negative b over 2a. If you get it in this format, you can just read off. If that was a plus here, it would have been a minus when I write it down. If that was a negative, then it's a plus. But that's whatever it is. If it was plus 4 there, it would have been plus 4 here as well. So that would be my graph of, what did I call it? G. So I can put the name G on. What is the equation of the axis of symmetry?
X equals to
Fantastic. X is equal to 2. Just a few things here, notes. When is a graph increasing or decreasing? We know it from straight lines. Straight lines that go positively has an increasing gradient, right? And it's negative, then it's decreasing. Does this happen in a parabola?
Yes.
It's not a straight line, but it does. First, decrease. It's still like a straight line. And then it increases. And if it was this shape, we would have said first it increases till the turning point and then it decreases. When you're going to be in hyperbolas and exponential graphs, as long as the thing makes this move, it's increasing. If it goes that way, it's decreasing. That's the first note. Then I need transformations. If I do transformations and it's in this form, it's so easy. If I say, listen, pick up that parabola and move it 3 units to the left and 2 units up. Take the graph, is it going to do this? No, you're just going to pick it up and move it left and up. So the shape is going to be the same. The only thing that's going to change is your turning point. No, ma'am, the x-intercept is also going to change, yes, but in your equation, the turning point's all that matters. Now tell me, the turning point used to be what? To a negative 4. Now it's going to be 3 left. Don't make it right. I'm saying left. Now it's not girls the other way around. I'm saying in plain English. 3 to the left. So where's your turning point then? Negative 1. It's not inside the equation where the x has to do the opposite of what she's saying. The y value is negative 4 and it has to go to up.
Negative 2.
Okay, so that's going to be the turning point. So what changed in this equation then? Does the a change?
No.
It'll still be y equal to 1 x. But the turning point's now going to be negative 1. What do we write? Ah, you're so clever. Now it's inside of the equation with the boy and girl stuff. And negative 2? Still negative. So you can see how nice and easy that is actually once you know what you're doing. But it's all about the turning point. So if it was in the other equation, y equal to ax squared plus bx plus c, it wasn't a nice question to ask. They're testing whether you know. You just have to look at the turning point because the shape is going to stay the same. It's just moving left and up or right and down or whatever the case may be. That's it. Okay.